Hello, we are presenting a case study on the Linux operating system. We are a group of three, Ankit, Apurv and me Yash. In this, we will talk about the history of Linux, how Richard Stallman began his GNU movement, and how Linus Torvald wrote the Linux kernel initially. What were the main design principles that he chose? And then the focus will go towards the main kernel design, the monolithic design of the kernel. How are the processes managed and how are they scheduled? How are the memory managed to be distributed among these processes and the other threads requiring it? And what is the main file structure used in the Linux OS? Linux is a modern, free operating system based on the Unix standards. It has been designed to run efficiently and reliably on the common PC hardware, but also runs on a variety of other platforms like mobile and other handheld systems. The core Linux operating system kernel is entirely original, but it can run much existing free Unix software, resulting in an entire Unix compatible operating system free from any proprietary code. Now let's go down the timeline and discuss about the initial days of Linux. During late 1980s, the market was mainly dominated by DOS by Microsoft, the Macintosh OS, and the Unix. There was a main drawback for all these three operating systems. They were all proprietary and protected. Nobody can view their source code or can even take it from each other and share among themselves. The developing community of this was restricted to the proprietary companies only, and no other developer around the globe could contribute or could play around with the code that they had written. It was the time when other developers and people were looking for free open alternatives where they can view the source code and play around and tinker with it so that they can make use of the codes written and can modify them to their own good. At this time, a guy called Richard Stallman started the GNU movement. Well, the GNU stands for GNU is not Unix. Yeah, it's a recursive acronym. Its major aim was to develop code which is free for everyone to use, people can contribute to it, and people can take the most out of it. It was not proprietary or meant for any other commercialization purpose. It aimed at building an open system where people can contribute and people can take advantage of the code. Under the GNU movement, developers from around the globe developed many applications and programs with the Unix system and the other Macintosh and the DOS systems. But there was one major problem with all these. They lacked a proper OS that could handle these applications and manage the memory allocation task for them. It was the start to the Linux system. In September 1991, Linus Torvalds, a second-year student of computer science at the University of Helsinki, developed the preliminary kernel of Linux. It was not meant for any commercialization purpose or any proprietary use. It was just out of his hobby, and he uploaded the code what he had written over the internet so that every other developer could contribute to the system and could make good use of it. Very soon, his project was no more limited to himself. It was backed by millions of coders online who contributed and enhanced it because it met the global need. Very soon, it also got licensed under the GNU General Public License, thus ensuring that the source code will be free for all to copy, study, and to change.
Now moving on to the design principles of Linux. Linus started this operating system as a hobby, and he just wanted to do it because he wanted to do it. He didn't see any commercial application or something like something on the lines of Microsoft. So there was this Professor Andrew. he had made the Minix operating system. That was basically a microkernel based operating system, and he criticized Linux a lot on his monolithic design of the kernel. He said that Linux was obsolete, but Linus actually did not give much about what he said, and he went on to make it a GPL licensed operating system, and a lot of people started following it and contributing to its code, and many people started using it. So basically Linux is a multi-user multitasking system licensed under the GPL, and it has something like some semantics like the Unix system. Its main design focus on the speed, efficiency, and standardization. It can be used in two modes: dual mode, which has user and supervisor mode. The supervisor mode or the kernel mode has the control over all the resources. So it links your hardware to the software. So it's like an interface. Moving on to the components of a Linux system. Basically, the Linux system has two spaces: the user space and the kernel space. As I already said, that the Linux operating system is based on a monolithic kernel. The kernel is the interface between the system and the hardware. The user writes the instructions that are to be executed, and the kernel makes system calls to run the instructions given by the user. The kernel space also handles interrupts and exceptions. It synchronizes and manages various parts of the system and puts them together. Now, more about the monolithic kernel of Linux. So basically there are three types of kernels nowadays: a monolithic kernel such as Linux, a microkernel that was Minix made by the Professor Andrew, and we have a combination of both known as the hybrid kernel. So focusing on the monolithic kernel, they are the opposite of microkernels, mainly because they not only encompass the CPU memory but also include other device drivers, file management systems, system server calls, etc. So they tend to be better at accessing hardware and multitasking. This, however, can cause some problems because the more things run in the supervisor mode, the more things can bring down your system if one doesn't behave properly with it. So some advantages are more direct access to hardware for programs, easier for processes to communicate between each other. But a bigger disadvantage is that it has a large memory footprint. So what basically this is that all the modules get combined into a single executable. So you can actually load and unload kernels and the utilities on the fly, so without rebooting the system. So it's basically like if you want to update your Windows, you have to shut it down and then the update happens. But in Linux, it's not this way. You can update it while you're running the operating system. So this is somewhat different from the general operating systems we use. So a microkernel like Minix, it takes the approach of only managing what it has to. So it's like very localized. It only keeps the CPU, memory, etc. And pretty much everything in a computer can be seen as an accessory and can be handled in the user mode. So they have an advantage of being portable because they don't have to worry if you change your video card or your operating system, as long as the operating system has the same configuration. Microkernels also have a very small memory and installation footprint, so they tend to be more secure. The pros are portability, small memory footprint, and security. So moving on to the monolithic kernels, there's something called as loadable kernel modules. As I already told, you can mount and dismount, load and unload your modules on the fly. So you can keep what you want and you can remove what you don't. So if you're using the Linux OS for, say, making a mobile system, so you can remove all the things that are related to the computer, like Ethernet drivers, etc., printer drivers. So you can remove those and you can only keep what you require. So this is a very big advantage, and you can tailor the operating system to your advantage, to what you want to do with it, and you can remove all the extra stuff. So it's short, it's small, and it becomes fast. So customization is easy basically. Model management ensures effective resource usage and mount and unloading of your procedures. Kernel synchronization allows it basically allows critical sections to run exclusively. So if one module has a critical section, the other modules cannot run the critical section because there might be some interruptions or interference with the functioning. Yeah. Going back to the components again, as you can see, there are two spaces: the user space and the kernel space. So in the user space, the user can do pretty much whatever he wants, given that he does not interfere with the. So what what basically happens is the user can do whatever he wants unless he interferes with the kernel operations. And once that happens, or once he violates something, or once the kernel realizes that something unstable might happen which may cause corruption, the kernel takes on the control and then executes some instructions that bring back the operating system to stability. So that was the add-on to the components, and now Yash will explain the latter part of the slide.
Now let's discuss about processes and threads. So what are processes? Any program that is claimed to be executing is called a process. Well, all these processes have been assigned a unique ID called the process ID or the PID. The use of this ID is that whenever any application needs to make a system call or modify or wait for another process, they can refer it by the PID. Each of these processes have their own environment which is inherited from its parent. Passing the environment variables among these processes and inheriting variables by a process's children are the flexible means of passing information to components of the user mode system software. In the Linux system, both the processes and threads are represented internally in a very similar manner. A thread is simply a new process which happens to share the same address space as its parent. For a multitasking system, a process has to be at least in the following three states: the ready state, the running state, or the sleeping state. All the processes that are ready to be executed but are without the CPU currently are in the ready state. If there is only one CPU, then apart from one process, every other process has to be in ready or the sleeping state. Coming to the running state, the process which is actually occupying the CPU currently is called to be in the running state. All other processes that are waiting for other resources or the present activity is dormant. Example, they are waiting for the internal output devices or anything else, is in the sleeping state. Now, process management is the most important part of the process context. It is the information that the scheduler needs to suspend and restart the process, and we shall discuss that in the details in next slide. Process scheduling. Linux, being a multitasking system, can execute multiple programs at the same time. But the thing is, if there is only one CPU, then how come many programs can run simultaneously at the same time? The answer is, they utilize the concept of time sharing and scheduling. There are many ways of scheduling the processes, but the way Linux OS schedules its process is by the process of round-robin scheduling. It is basically that all the processes have been given a certain amount of time before which they get automatically swapped out and get replaced by other processes. In Linux, this time is 100 milliseconds and is called one quantum. At the time when the process is selected to go inside the CPU, it transfers its state from ready state to running state. Once the time quantum for it has been expired, it is swapped out and is brought back to the ready state, or else it might go in the sleeping state if it requires or it is waiting for any other internal or output device or command. From this sleeping state, once it acquires the resource, it goes from sleeping state to the ready state. This mechanism to determine which process should get into the CPU is called process scheduling. Now, in the upcoming slides, Apur will take over and give you a live demo of the Linux environment and discuss about the file system's Linux OS.
Linux file structure is different from our Windows file structure in the sense in Windows we have different drives, but in Linux the files are grouped according to their purpose. For example, command files, data files, etc. So some of the examples are bin. Bin are the commands used during boot up, and proc is one of the file management system which is not, it is a virtual system which actually doesn't exist, but it is the imagination of the kernel itself. Let's start with the demo of the commands now. Go to the terminal. Now you can get the name of the system, and cd ls you can find what all the folders are inside the directory right now. CD, you can move to a specific folder such as CD. Suppose we have USB. Now we are in USB. If you want to come out, you can type CD dot, you will come out. Now suppose you want to create a directory. Now let's name it something Linux 1. Now we have created it. Now you can go inside. Now suppose you want to create a text file. 18.txt. Now you're inside the text file. You want to suppose hello. Now if you want to come out of this, press Ctrl C and your text file will be saved. Now you can view the content of the text file. So that's it. Now let's see some commands to suppose history. What all commands you have typed up till now? Very much. A lot. Now let's suppose the one of the the best advantage of Linux is you can directly install some of the applications. You have to just specify sudo apt get. Sudo is the super user mode and app is advanced package tool. Now okay, now let's try installing Shutter is one of the to get the screenshots. Now it will install the information. You want to continue? Yes. Now let's see some other commands. Now suppose we want to view what so this tells us D stands for the directory and the RW and X. R stands for read, W stands for X. So this is first is the owner and then is the user. So the third one is for the world. So as we can see in the text file, the owner has read write and the user also has read write permission, but the world has only the read permission. Now let's see how we can modify this. um, the values are for read is 4 and for write is 2 and for execute is 1. So let's chmod is the command to modify it. Chmod, if we specify 666, that means 4 plus 2, that is we have read and write permission both. Oh sorry, I didn't specify the file name. 18.txt. Okay, now let's check if it has got modified or not. Yeah, as we can see, all have read write permission now. So now what else? How do you remove a file? rm and just specify the name of the file. What is it? add.txt. So you have removed it. Now let's see if it is nothing exists in the folder. So that's all.
With this, we come to the end of our case study on the Linux operating system. Thank you for watching.